Hello everyone. What we have here, we have graph of acceleration, and when we look at the first interval from 0 to 5, we see that acceleration is constant and the value is actually 2 meters per second square. And when we look at the second interval between 5 and 10 seconds, we see that acceleration is 0, also constant, but 0. And finally, third interval between 10 and 15 seconds, we see that also acceleration is constant. However, the value is minus 2 meters per second square. Also, we know that the position of this object when time equals to 11 seconds, the position is plus 59 meters. Also, at the same time of 11 seconds, the velocity is 8 meters per second. In previous problems, we always be given the initial position and velocity when initial time was actually t0 equals 0 second. But this time is a little bit different, and we're gonna somehow to overcome this problem. And I assure you that it won't be so difficult as maybe you think. Okay, let's go over the parts of this question. Part A, we're gonna need to find Vt, function of V of t for each interval. Then we're gonna have to draw the graph of V of t. Part C, we're gonna find function of x of t for each time interval, and also we're going to draw the function of the graph of x of t, and the final part we're gonna find average velocity between initial time of 5 seconds and till final time of 15 seconds. Okay, let's go over the solution. And as you can see, I will start from the final interval because, again, we know only the position of this object when time equals 11 seconds, and the velocity also at this time is given by a value of 8 meters per second, and 11 seconds, okay, is actually lives, let's say, in third interval of time. Okay, now we know that acceleration in the third interval is constant and the value is minus 2 meters per second square. Now we will use this formula for the velocity. V0 is actually the initial velocity at time t0, and the initial velocity and initial time for the third interval is actually 10 seconds. But at this point we do not know what is the velocity, but we do know the acceleration, which is minus 2. Okay, so the expression for the velocity in the third interval of time is given by this expression. Again, I do not know what is the initial velocity when time equals to 10 seconds. However, if I'm going to use this information, okay, I think I'm gonna find the initial velocity, which means I will go and substitute the velocity of 8 when time equals 11 seconds. Okay, and 11 minus 10 is actually 1. 2 times 1 is 2. Okay, now eventually we get that initial velocity of this object when t equals 10 seconds is actually 10 meters per second. And finally, we can see this final expression for the velocity when we are talking about third interval of time. I'm saying that this function lives, let's say, lives in third interval of time between t 0, not 0, 10 and 15 seconds. Okay, it's like we're going backwards from third interval to the second and then finally to first interval. Sorry. Okay, now what do we know about second interval? And we are talking about between 5 and 2 seconds. We know that acceleration is given by this value of 0 meters per second square. Also, because the acceleration is 0, okay, then the velocity will remain constant. How do I know this? If I look at the previous expression of velocity, and when I substitute t by 10 seconds, we will get 10 meters per second, which is okay, it's initial velocity for the third part, but is also the final velocity of the second part. However, on the second, not part, interval of time, because we do not have acceleration, the velocity will be constant. Okay? And this is our function of velocity for the second part, second interval of time. Now let's go and see what we can get from first interval between 0 and 5 seconds. Okay, again we're going to use this formula because when we look at the first interval we do have acceleration of 2 meters per second squared. Okay, so the expression, not final expression of course, because we still don't know what is the initial velocity when we are talking about initial time of 0 seconds. Okay, and we need to find the initial position, okay, of this expression of v of t. So how are we gonna do this? We know that when t equals 5 seconds, okay, t equals 5 seconds, okay, then the velocity is 10 meters per second. Why? Because again, when we're going to second part or second interval, and we already told that the velocity is constant in this interval. Okay, so also when we're talking about t equals 5 seconds, okay, so the velocity will be 10 meters per second. Okay, so from this step we see that initial velocity when t equals 0 second, okay, we get 0 meters per second. So final expression for v of t is given by 2 times t. In conclusion, okay, the function that represents the velocity of this object for any interval of time, let's see that first interval is linear function. I'm sorry, I think no, it's okay, it's linear function, no problem. 2 times t. Okay, second interval, okay, because we do not have acceleration, so the function is constant or velocity is constant. And when we go to the third interval, okay, the expression that we got is given by this expression of t 10 minus 2 times t minus 10. Okay, so next part we need to draw the function of v of t for any interval. Okay, when we look at the first interval, okay, when t equals 0, then the velocity is 0. And when t equals 5 seconds, okay, 2 times 5 will give us value of 10 meters per second. And of course, as I said before, the function is linear. The slope, okay, the definition of slope is actually acceleration, and the value is 2 meters per second square. When we go to the second interval of time between 5 and 10, we see that the velocity is constant because we do not have acceleration there. And finally, the third interval between 10 and 15 seconds, okay, we also have linear function. However, the slope slash acceleration is negative. So this is our graph of v of t. Okay, part C, we need to find a function that represents the position of object. Again, we are going backwards from the last interval, okay, then we're going to the second interval, and finally we will go to the first interval, and that's it. Okay, what do we know about third interval? We know that position of this object when t equals 11 seconds, the position is actually 59 meters. Also, we know that acceleration is given by minus 2 meters per second square. Of course, we're going to use this function or formula of position of x of t when we know that there is acceleration. Now, I do not yet know the initial position when t equals 10 seconds. I do not know also. No, I'm sorry, I do now know that initial velocity from previous parts was actually 10 meters per second when t equals 10 seconds, okay? And of course, as I said a few seconds ago, acceleration is given by minus 2, okay? Minus 2 divided by 2, which will give us minus 1 here. Okay, so from this step, we need to find x0 when time equals to 10 seconds. So we're going to use this data, okay? I will substitute x of t by 59. However, instead of t, I will substitute the given data of 11 seconds. Okay, so 11 minus 10 will give us 1. Again, here also 1. Then we have this expression from in this step. So x0 plus 10 minus 1 is actually 9. And finally, the initial position when t equals 10 seconds is given by this value. So finally, we can see that this is the expression for position at any given time of t for the third interval of time. This is the initial position when t equals 10 seconds, which is initial time for this interval of time. Okay, and also in previous part, we also calculated that initial velocity when time equals 10 seconds is actually 10 meters per second. Now we're gonna look and try to solve and find the function for position for second interval between 5 and 10 seconds. Okay, we do know that there is no acceleration, so we're gonna use this formula because there is no acceleration. So again, the initial time for this interval is actually 5 seconds. So I'm gonna find in the next steps the initial position for this interval of time when t equals 5 seconds. Now, from the previous part, we also calculated that when t equals 5 seconds, the velocity is 10 meters per second. Also, we also saw that velocity actually in this interval of time is constant, 10 meters per second, because there is no acceleration. So, also I know from the previous part, okay, from the, not previous part, I'm sorry, from previous interval, when we're gonna substitute t by 10 seconds, okay, then we'll get 50 meters. And we're gonna use this data. How? Let's see. Now, when x equals 50 meters, okay, the time that we're going to talk about is actually, as I said before, 10 seconds, which means when t equals 10 seconds, the position is 50 meters. Okay, so 10 minus 5 is 5. 10 times 5 is 15. Not 15, 50. So the initial position when t equals 5 seconds is actually 0 meters. Okay, so finally we have the expression for position of the object for second interval of time. This is linear function, of course, because again we do not have acceleration at this interval. Now, finally, we need to find the expression for position of this object for first interval. Now, here we do have acceleration, so I'm going to use this expression. Now, again, here, like in previous intervals, I do not know what is the initial position when initial time of this interval is 0 seconds. Okay, but I do know the velocity, okay, when time equals 0. Why? Let's go for the previous part. Okay, this is the function of velocity for the first interval. When we use or substitute t by 0, we will get 0 meters per second. So I do know what is initial velocity for the first interval of time. Okay. Now, so initial velocity is 0, okay, plus t squared. It is also almost final expression for the function that represents position. Now we need to find x0. Again, when t equals 5 seconds, which is actually the final position in first interval, or we can say its initial position for the second interval of time, okay, then x, let's say initial for the first part when x final for the first interval when t equals 5 seconds, it is actually the final position, initial position, for the second interval of time here. So it equals to 10 times 5 minus 5 equals 0 meters. So when t equals 5 seconds, the position, which is final position for the first interval, okay, is 0, which is again initial position for the second interval. Okay, so 0 equals to x0 plus 25. And finally, we see that initial position for the first interval when t equals 0 seconds is actually minus 25 meters. And finally, we get this expression for position of the first interval. In conclusion, okay, we have this expression for position for every interval of time. Part D, we need to draw this function of x of t. Okay, when we will substitute t squared by 0 squared, which is actually initial position of this object, which is actually minus 25, somewhere here. This is the point, this is initial position. When t equals 5 seconds, we can use this expression. Okay, 5 minus 5 is actually 0, so it's 0 meters, which is this coordinate. And when t equals 10 seconds, we can use this expression, or even this expression. 10 times 10 minus 5, so it will be 50 meters. So I'm talking about this coordinate. And final position, okay, when the final time is 15 seconds, of course we're going to use this expression, and you can check later, it's actually 75 meters. Now, when we are talking about second interval of time, we are actually know that there is no acceleration, so the velocity is constant, and we also see that it actually is a linear function. So we will use those two coordinates, and we'll add just a straight line, which is actually a linear function. Now let's go and see what we can say about first interval of time. As you can see, it's actually a parabola, okay, and the coefficient of t squared is actually positive, so the parabola, let's say, is happy, okay. Also, we know that initial velocity, if we go to the graph, also we see that velocity is 0. Now, at time of 0 seconds, okay, the slope, if we're going to talk about, let's draw some parabola, okay. Okay, the slope here, okay, is actually instantaneous slope at this point of time. But the definition of the slope is actually velocity. So, therefore, we know that velocity here, instantaneous velocity, at this point is actually 0. Okay, v 0 when t equals 0 seconds is 0. And also we said that parabola is happy, something like this. So I guess that graph will look something like this. Oops, sorry. It worked before. Oh, now it's better. Okay, let's combine those points, and it will look something like this. Okay, and the final part, it is also a parabola. However, if we'll open those brackets, we will see that coefficient of t squared is minus. So it will be unhappy parabola, something like this. Now, when we are looking, or will look at time of 50 seconds, the velocity is given by 0 meters per second. Or you can actually add t 15 seconds here, and you get that velocity equals to 0 meters per second. But as I said before, this is actually instantaneous velocity here. instantaneous velocity or instantaneous slope at this point. So here v, when t equals, let's say final 15 seconds, equals 0 meters per second. So I'll guess that parabola will look something like this. So this is our graph of x of t. Okay, final part. What is final part? We need to find average velocity between initial time of 5 seconds and final time of 15 seconds. Now, the definition of average velocity is given by delta x divided by delta t. Okay? Now, we have two ways to solve this. Now, first way, okay, I'm gonna use graph of v of t. In previous videos, I explained that actually the area under v of t is actually delta x. Okay, so a delta x between 5 and 50, okay, is actually, I think it's called trapezoid or something like this. Okay, so to find this area we need one base, which is 5, second base 5 here, you can see it here, second base between 15 and 5 equals 10, you can see it here, times height, which is 10, you can see it here, divided by 2. And eventually delta x equals to 75 meters. Now, finally we can calculate the average velocity, which is by definition is delta x divided by delta t. Again, delta t is 15 minus 5, so it's 10. So finally, average velocity, the value of average velocity is 7.5 meters per second. Now, sometimes someone can ask, okay, how you can add this value in graph of v of t? It's not so hard, because as I explained before in previous videos, average velocity is something like, you can ask what will be the constant velocity, okay, constant velocity that I can travel from initial time to the final time, but I will not change my velocity, okay? It's actually will look something like this, and you can check if you will calculate this area, okay, which is base times height, you will get 75 meters. This is one way to calculate average velocity. Second way to calculate velocity, we actually can use the definition of displacement, delta x, which is actually x final minus x initial. Now, when we're talking about the final time, which is 15 seconds, of course we're going to use expression for the position when we're talking about last interval of time. So we are going to use this expression, and of course finally we're going to substitute this t with 15 seconds. Initial position, initial time and initial position, we are talking about 5 seconds, so we can use this expression. Okay, why I use this expression? Because let's go back. We saw that, well, actually I can use also this expression because time of 5 seconds, okay, we can see also in first interval and in the second interval. but I choose to use this one. You can check like minus 25 plus 5 squared equals 0, or 10 times 5 minus 5 also will give you value of 0. So it doesn't matter, you can use or this expression or this expression to calculate the position of this object when t equals 5 seconds. Okay. So when we substitute t equals 15 seconds here and t equals 5 seconds here, we will get that the value of the final position is actually 100 minus 25 minus initial position, which is 0. So displacement delta x equals to 75, which is actually the same value that we saw in first way. So it's the same, so it's okay. And finally, we can calculate our average velocity again. We will take delta x divided by delta t, and again the value of average velocity between initial time of 5 seconds and final time of 15 seconds, which is equals to 7.5 meters per second. Again, someone can ask you, okay, how you can add this value in graph of x of t? You just need to take initial point, final point, and just draw a straight line like this. Okay, and finally you will take delta x divided by delta t, will give you again 7.5 meters per second, because this delta x is 75 minus 0. Okay, and interval of time delta t, which is 15 seconds minus 5, will give you value of 10 seconds. So I guess it's enough at this point. I will see you in the next videos. Thank you very much.